Hey everyone, Juan here. Welcome to SQL Lingua Franca, the podcast about analytics that reveals what the documentation does not cover.
SQL Lingua Franca. Bio.
Today, I have as a guest one of my good friends, Tony. He's a data engineer consultant, and he has some really interesting ideas about how to make the experience of a developer much better. Tony, before we even get started, I would like you to tell us a little bit more about you as a person.
Right. So my background is in biomedical sciences. I've done genetics research at various universities here in the Netherlands, in University of Amsterdam and University of Utrecht, and in America at Stanford University, doing a bunch of things in the lab, but also in bioinformatics, which is where my programming career started. And from there, I kind of rolled into the consulting world for R&D and biotech, and doing that work, I really realized I love working with data and infrastructure and just general software engineering. So I was really drawn to the data engineering parts of my previous jobs, and that sort of led me into where I am today, which is data engineering consultancy.
Indeed, I don't think too many people start as data engineers. There's generally some sort of progression.
Mm-hmm.
Now, you have a very specific topic for today,
Mm-hmm.
but I really want to ask this question. I happen to know that you have done quite a lot in the field of biology.
Yes.
And maybe for those of you listening, I know you have actually worked in a lab,
Mm-hmm.
properly taking notes, doing little experiments.
Mm-hmm.
Can you maybe tell me some of the biggest difference between that past and what you currently do?
So you're specifically talking about doing lab work and doing data engineering work? Or do you mean bioinformatics and data engineering?
Yeah, let's say everything biology and what you currently do.
Right. So with biology, whether it's academic or R&D, really your projects are more long-term, right? So at the end of the day, you're really trying to expand the knowledge in the field, whether that is to write a paper in academia or to bring out a product eventually within your company. And doing lab work to me was honestly very robotic. So it's very fun to plan your experiments and to really think about how could this work, make your hypothesis, and then you can just go into the lab and try it out. So there was really a lot of that experimentation there. But to me, where it got mundane was just doing the motions of actually doing the experiment, and I wasn't really always very good at like small motorics, so that wasn't my best skill. But then once you generate the data through an experiment and you have to do data analysis, that's where things were clicking more for me. And for the people listening in here, what you should imagine in genetics is these are huge data sets, right? We're talking about 3 billion nucleotides in the genome. These are essentially letters that encode all of your genes. And a typical data set might have hundreds of millions of measurements of these. So you can imagine that's quite massive.
Yeah, it's really one of the first big data problems.
Exactly. Yes, it was one of the earliest big data problems. And that really also forced me to really think about how do you deal with big data? What is really the workflow working with that? And there's definitely some similarities in what I do today as well with that. So I think it was nice to get those practices in. Um, and generally, it's so complicated. There's a lot of things you can find in the data. So you can spend an endless amount of time finding new patterns and new hypotheses from the data, which was really fun.
Indeed, what I can imagine is if you plan to find insights in a data set that big, you really need to become an expert in some sort of data architecture thing.
Mm-hmm. Yes.
Even if that is like how to make sure that the Spark cluster still runs or Hadoop or whatever it is that you have, working in a data set that big is clearly a completely different beast than a database with 30,000 rows.
Absolutely. I mean, we did all the HPC stuff back in the day, and it was really fun, but definitely challenging. And something else that you learn with these massive data sets is just doing like proper modeling and statistics. Because the thing is, you'll find a lot of patterns. Like if you just do regular statistics on a data set like that, you'll get, if you do a t-test, for example, you'll notice your 5% error rate, right? Like it would be hundreds of false hypotheses. So you really start to be more, let's say, systematic about how you gain insights from your data set, which I think is also a really good practice to have, also with smaller data sets as well.
Yeah, indeed. And then I guess it's a very nice bridge to tell us what exactly you do nowadays.
So I'm a data engineering consultant, so I help companies set up their data engineering infrastructure, help their stakeholders generate ETL pipelines, reporting, anything they really need to get their business running. And I mostly specialize in the fields of healthcare and life sciences. So I know quite a lot about these domains. So I can also really talk in their language when we're setting these things up.
Of course, and those industries they're particularly known for having their own demands and yeah, their legal concerns as well.
Absolutely. One of the biggest things in these fields, if we're talking about healthcare specifically, for example, is privacy is of utmost importance. There's a lot of regulations that you need to abide by. And generally, there's a lot of messy data sets. So there's also definitely a lot of importance in data quality as well.
For sure. But Tony, today we, even though that's a very interesting topic, and now I'm realizing maybe we should do a follow-up episode just on that. I know today you came because you have some very interesting ideas about developer experience, and I'm very curious about what you have to say on the topic.
Right. So, developer experience, if you think about uh, you as a customer interacting with any application or tool, we are all very well familiar with the UI or the user experience, right? And we all know intuitively how important it is to have a good UI to really be able to work with something. Can you imagine if ordering an Uber would take you 30 steps to do? No one would like that. You would get very frustrated. You would just pick up your phone and call. You
Indeed.
wouldn't use the Uber app anymore. Uh, Yet, when it comes to development, we sometimes forget that it's the same in that sense.
It's crazy because we are super forgiving with like these legacy applications that we work with on our own companies. But we wouldn't put it up if it would be like something that you pay for, some sort of social media app or whatever it is, or even a web page.
Right. And if you think about it, in any company, the people are the ones that actually provide the value. When you are working your data team, it's all about how much scope can you handle with your given resource and team. And if you're just spending a lot of time on low value repeated activities, it's a waste of time. So even if you increase the productivity of every person in your data team by 5 to 10%, that's a lot of additional value that you can be providing back to the company. So to me, it's one of the obvious bottlenecks to think about, right? Um, so
Yeah, indeed. So very selfishly for the companies, a reason why they should care is because with a better experience, you can actually ultimately turn that into money that you're saving. But I think there are plenty of other reasons to say that if you're listening to this and you're building any type of product, I guess in this case more of a data product, there are still some really good reasons to think about the developer experience. Maybe before I mention the ones that I have in my head, Tony, do you have some others?
sorry, what was the question specifically?
Yes. What are some good reasons for which product people building data products should care about developer experience?
Well, one was what I just mentioned. It's just the amount of scope a team can handle. And you mentioned reducing costs, but I would not just think about reducing costs. It's also about improving value. Because if you think about it,
Yeah.
let's say, I as an engineer have, let's say, 10 or 20 data asks. Let's just give that as a metric here that I need to work on every week. If it takes up all my week, I have no time to like build out new capabilities that could be interesting. Let's say a forecasting model for our accounting department or anything else that would be valuable for the company. Whereas if it takes me half my work week, I can then also build new things. So it's not just about saving costs, but it's also about being able to provide
Yeah.
more value through new development streams.
The, the opportunity cost.
Yeah, exactly. It's the opportunity cost, right? I think that's the biggest reason to do it. But other reasons could be to kind of streamline the development experience so people have a minimum quality of things they're committing, right? So if you think about this, we do this all the time through CI/CD, right? But we don't think about uh, how do people do this when they're developing, right? So you have control over the process when they push code to the repository. You have control over how it gets merged, how it gets deployed. But then there's this whole like black area in front of it where essentially you don't know what's happening, and at the end they just give you some piece of code, but that doesn't really tell me anything about whether they uh, did it right or how they went through it. And more often than not, when scope gets really large, it gets very difficult to also confirm everything, right? So if you're thinking about data quality and let's say code quality, things like this, sometimes when teams are really busy, it gets kind of pulled under the rug, right? So what I'm thinking is, the more you can automate the correct behavior, the better the overall quality is going to be. And to do that, you have to think about the developer experience. I measure a lot of things. I have a smartwatch, for example.
See?
Yeah, right. So this helps me to measure, my heart rate, my sleep, how many steps I take a day, and that helps me to figure out, am I working towards my goal of becoming more healthy? If I would have to write these things down all manually, I wouldn't do it. It would take too much time, and then that would be disregarded. Same thing with a development experience. The more you can automate these things, the more of them actually get done, if that makes sense.
Yeah, of course. I also happen to have a hot take about it. That is, it doesn't really matter on the why you're doing it, because I firmly believe that the generation that grew up with TikTok and all of these apps, it's really not gonna fly with clunky apps and interfaces. And right now, yeah, of course, the people that started their careers in the 70s or 60s are still the ones making the big decisions of what software to purchase. But maybe I'm gonna be wrong. In 20 years, we're gonna have this conversation again. But I really think the shift is just gonna go because people are not gonna be that forgiving as we're right now.
I think it's not really a question about forgiving. It's just a competitive disadvantage for a company. If you're going to spend so much time dealing with a legacy system like that, you have no scope to actually build a competitive edge against your competitors. So you're going to fall on the wayside. Except if if you've been around for a long time and you have a giant moat around your business, that's a different story.
Yeah.
But for new businesses or on the block, that's definitely not
Yeah.
the way to go.
It reminds me, very early in my career, I met somebody whose whole job was to jump company to company, updating their SQL servers. And he used to hate Snowflake. But nowadays, I haven't heard of companies that do like updates anymore, at least manually. It must still happen, but I see it much less.
That makes total sense, right?
Yeah, for sure. So we're really taking away some of that. Maybe let's let's talk about what are the very specific things a product can have to make your experience better.
Right. I think one of the most important things to think about is what information or contexts does someone need to do their job, and then make it as proximal as possible. So, what do I mean with that? Let's say you have an analytics engineer and they're working a lot with creating DBT models. You want to be able to give them things like their DBT lineage within their code editor. So they can kind of travel around, see the files, see the code, and then see how the lineage updates, maybe get columns from the data warehouse. And of course, anyone that's been working with DBT knows VS Code plugin DBT Power User actually does that. But why I
Yeah.
think that's successful is because it makes it proximal. I don't have to do context switch. I don't have to go to a website or a separate service to see this. So what I'm thinking, and I've had a lot of conversation with people in the data field about this as well, is what is actually the information you need, and how can you make this as proximal as possible to your working environment to improve this experience. Because you think about it, we're context switching all the time, every
Yes.
day, and the less you can do of that, the easier it is to stay focused on what you're doing. So I think that would be one of the guiding principles there. Um,
Yeah, of course, that makes sense. So it reminds me of whenever you hit a really big query
mhm,
and it takes, let's say, more than 3 minutes to run.
mhm.
Like in that moment where you have to like disconnect for a second, go get a coffee, like you end up losing some of the concentration. And to a lesser extent, going from one tool to the other one. And sure, you can have like something, the documentation in one monitor and then the tool in the other one, but just having them as closely bundled as possible in the moment that you need them
Right.
is really making a huge difference.
And I think companies like Snowflake do this very well. If you look at their UI, you'll see that whenever you run this long query, you'll have your query profile right there available for you to view visually. So you can immediately see as you have your query, what's happening here? Why is this taking so long? And you don't have to like go to a different page, look at the profile, look at the history, right? These are all additional steps, but it's nice to have it there. It makes sense because you typically do this a lot. And the way I usually advise companies to start building something out like this is very simple. First, when you have your data team, you want to have very well managed centralized development environments. And what I typically recommend is using dev containers for this. Um, so in VS Code, you can also use
Yes.
VS Code dev containers for this. And what a dev container is, it's essentially a Docker container. So you have some very basic definitions. You have your Docker file, and you define your container just as normally. Um, but then you also have some JSON configurations for the VS Code server. So what it's doing is it's spinning up a Docker container and then runs a VS Code server in there that you can connect to then remotely, right? Like through Docker. Um, so
And
it's
it,
really powerful because you can configure both the computing environment and the development environment all in one place. And then you can really start to build out a lot of nice features for your team. So you can think about custom linters, you can think about custom code highlighting. This is something I've done with a client of mine where,
interesting.
yeah, so you can, for example, your YAML files, uh, you can have a VS Code plugin. I think was the Red Hat YAML plugin, if I remember correctly. And in there, you can actually define JSON schemas that tell you exactly what the YAML file specification should be. So when I have my YAML file open, it will just give me a red underline like, hey, you forgot to add a name or a description. But you can do this uh, uh, much more advanced, right? Depending on what's important for
Yeah,
your company.
the limit is the creativity that you have. And I think that solution, you haven't mentioned this yet, it solves a lot of the problems that you tend to have when you have larger teams, like
Mhm.
ensuring that everybody's in the same version of a software
Yes. Yes.
to reduce like compatibility issues. But also like you can pre-mount all of the locations that they need access to,
Mhm.
like this part of the data lake, this other part, and that just makes it much easier for them to just work with the data that you expect them to work.
Yeah, another example that I did with a client of mine was we wrote a custom wrapper around the DBT CLI. So, for anyone that has been working with Defer, I know I've seen a lot of analytics engineers struggle using it in a production environment because it's a bit confusing on how to use it initially.
Yeah.
Um, and then what we can do through that CLI wrapper is, we can get the production artifacts from S3 if they're stored there, or GCP or Azure, whatever you store it at. You get the artifacts, and then you can also uh, prevent them from running commands in the wrong way. So, for example, with a defer, if you have your data warehouse set up that you have, let's say, a raw table in a database, and you build like a lot of views on top of it. Let's say you take the view down the line and you build everything upstream. If you do it with a defer statement, it's not actually going to defer. It's going to build everything,
Yeah.
which is what you don't expect when you used it the first time. It took me the first time looked at it half an hour to even figure out why that was happening, and then you can code it in and say like, hey, I see you're trying to do this. Just be aware of this, and then maybe you should run it like this, right? Or You can also prevent people from building everything upstream for a lot of expensive models. So you can say, hey, did you know that you can give them like feedback in a terminal? Did you know that you can build like just one parent up or two parents up instead of everything up? Right? So
Yeah.
it's like plus two or two plus. So you can do things like that too.
Honestly, I don't know if this exists, but I would love it if there would be some sort of extension that tells me by running this command, you're about to create these DBT models. In total, there are this amount of bytes,
Hmm.
and based on your contract, whatever with cloud provider, it's gonna cost you approximately this. Now, I know it's very difficult, and maybe a lot of companies don't want the cost to be that visible. But I think for us developers, analytics engineers, or whatever you are, having that information and that immediate feedback makes a massive difference.
Right, exactly. That's a great idea, and I think that's very buildable. Right, it will take some effort, of course, but the fact that you have your own managed environment and you're using a bunch of open source tools, and you have very good metadata stores of data warehouses like Snowflake and Databricks, this is very doable. This would be a great idea actually to implement in one of these systems. And my point is that with this environment, there's a lot of flexibility that you can add in there to really streamline the process for your company. There might be different things that are important
Yeah.
depending on the company. Um, but yeah, I think that's like a really neat starting point, especially when you're talking about analytics engineering work and kind of streamlining that with your whole team.
Yeah, and I've also seen the opposite, which is like the ugly situation in which some very senior people, or sometimes just one person, has managed to hack the data platform in a crazy way. And then when you enter the team, they tell you, yeah, you just have to create your own reverse tunnel and then this, and you have to create a VM, and then inside of that VM do this because it's not supported by this other thing. And you're thinking like, whoa, like the amount of knowledge that you need to first come to this conclusion and second to get started is crazy. Like, how do juniors even get started here?
This is uh, this is exactly you're hitting the hammer on the nail. I would say. Uh, I always tend to say, if you don't pay it forward, you pay it backward. So if
Yeah,
you don't spend the time to uh, make it as easy as possible for your junior engineers to onboard or to prevent tech debt, you're gonna pay it back later by
yeah.
you having to spend all the time to fix it. If you're the person building it, or if you're managing the team, if that person leaves, you have a huge problem.
Well, I have to confess that the last time I saw this happening, I really believe the person was doing it on purpose, just to keep himself forever with that job.
Yeah, that
But
happens. But I would say, people have this tendency in varying degrees. Um, and all I want to say there is, I think, if you see something like that, if you're leading the data team or if you're on the data team, you should really make sure that that's not acceptable. Like if you have
yeah,
some sort of uh, code review process, just don't allow the PR to merge. Simple. I mean, you have to have some sort of structure and culture in there to say, no, this is not sufficient. We need more than this. Um,
yes, you. I know this is very difficult to afford, but the best engineering cultures are the ones that have enough seniors to be able to debate each other.
I'm sorry, to what?
Debate each other. Like if you have one
Hmm.
senior that is deciding every single
Yes.
thing, it's very different than if you have another person like, yeah, I don't agree. We should use this
Yeah.
technology because of this other reason.
No, I agree. That's very important. And where I often see this go wrong, and I think that's a very good point that you mentioned this, is you'll have, usually there will be a huge, let's say, variation in the general, let's say, skill level in your team. And what tends to
Yeah,
happen is you'll have like one person that is a lot more skilled than, or a few people that are a lot more skilled than
for sure.
everyone else in some certain dimensions, right? What I what I think is interesting to see is that usually what I see junior engineers do a lot is they try to emulate them and then try to try to meet their level. They try to get as good as them on the same technical dimensions. Um, I think that is an understandable desire, but I would suggest people that have this desire to think about this in a different way. So let's say you have your team and you have some core services that you use. What you want to understand is how does it work and how can I make a simple change? So there's like a base set of knowledge that you need. So if you have your data team, understanding your data orchestrator, maybe the infrastructure, the data warehouse you're working with, that's a requirement, obviously. But then beyond that, I think it's important that you find like your own dimensions of technical expertise, uh, because otherwise you get into this point where you're kind of stepping on each other's toes, and it gets
For
more
sure.
tempting to get like this defensive and develop in this way on purpose, right? To sort of create this distance if you're all going for that same thing. This is something that I've seen in a lot of different environments. So when I was working back in biotech and academia, it's the same thing. When people are all aiming for the same goal, they start to become less cooperative, and there is no need for that. There's much more beauty and elegance and value, I would say, in a team where you have experts, but they're all expert in different things instead of trying to be expert at the same thing.
Yeah. I've I've seen companies where they make people compete either directly or indirectly. I remember I saw a company where you would get a bonus based on the number of PRs that you.
Oh no.
Yes. And what that meant is every time there was some sort of bug or thing that needed to be fixed, it was like drop whatever you're doing, leave the coffee there, go for it. There might be some money involved in this.
Mm. That
And
reminds you of, sorry that I'm interrupting you. That reminds me of
yeah,
the story about the bugs. The amount of bugs you fix give you determines your bonus. So wouldn't then people just introduce bugs on purpose and then PR that
yes.
back? Yeah,
Oh,
that's
yes, the cover effect. But in general, even if people are not trying to game the system, which they definitely will, I don't think it works too well when people are competing for goals.
mm,
It also happens when they say there is only room to promote one person as a manager, or when more indirectly, when you have a programming setup that
mhm,
every time somebody works and they make a commit, they immediately cause you some sort of a merge conflict.
mhm, mhm.
That's difficult because you do start resenting people and you're like, oh, I'm gonna work in the afternoon because I hate like spending some time on this. So in general, working towards a common goal and trying to reduce those friction moments where people are competing, to me personally, makes the experience much nicer.
I totally agree, and I think you hit a good point there. They call it Goodhart's law uh, when you try to when you make the measure the goal, it ceases to be a good measure. This is a very good example of that, and I think as tech and data people, we are especially vulnerable to that because we like to put everything in numbers. But
Yes.
that's a very precarious situation. So let me give you an example. If we're talking about testing, like let's say we're writing software tests, you always see metrics like coverage and things like that. And the only thing I'm thinking is, well, coverage it doesn't really tell me a lot. I can write a test that just touches a piece of code and just says run
Or
it, and did it run?
or one is one.
Yes, one is one. I mean, that's
Yeah.
and then, but you didn't really do anything useful. So that metric is completely useless. And then you see people trying to achieve that, and they actually make their code base worse by doing so.
Here's my hot take on metrics. The only way that you make that disappear is when you start measuring correlation.
Mm-hmm.
Just an example. Uh, if my system is working, customer happiness goes up, sales goes up,
Mm-hmm.
employees being sick goes down, and so on. Because if you start measuring something with a tunnel vision, like only this number,
Mm-hmm.
people are gonna start breaking other outcomes.
Right. It's the another example of that is if you have a restaurant and you see revenue go up, is this because people are liking your food or because you had good marketing or sales or some sort of other actions? It might actually be that people resent your food and they just never come back. So the better metric would be on a scale of 1 to 10, how much did you enjoy your food, or how many repeat customers do you have? So there's like a refinement process
Yes.
there essentially, and I think it's important to have that refinement process there. So what I often see happening in a lot of teams is, they'll be thinking about the metrics, maybe some KPIs, maybe, you know, SLAs, SLOs, SLIs. So they're thinking about
Yes.
service level agreements. But then it's like a one time exercise and it's set in stone and it's done. But that's not very realistic. I mean, the goal changes all the time. And then what I see happening is they say, well, it's not useful. We set it up and it wasn't really worth it. And then, you know what? Never mind. We're just going to stop doing this altogether. Uh,
Yeah.
which I think is a worse way to go about things. Um, it's the same thing with very popular topics like observability. I see a lot of talks about observability, observing every single inch of your system. But you do have to realize with every additional thing you observe, you make it more complicated. You can make it maybe slower to run your system, and there has to be some action at the end of it. If I
Yeah.
get pinged 100 times an hour, I'm going to start ignoring all those messages, and I'm going to have the opposite effect. I'm actually going to start to take less action. So I think it's really important to think very well about what are the metrics and how do we make it productive for our cause, right? And you can think of Occam's razor in there as well. So you try to make it as simple as possible, not have too
Yeah.
many moving pieces in there. Um, yeah, I mean, I have like a lot of opinions on that when it comes to writing code bases for data engineering work as well. But
No, for
yeah,
sure. But I think for every single alert that you have, there should always be some sort of ownership.
hmm
Like, it is this person that is going to be affected, and this person is responsible to fix it.
hmm
Additionally, it works much, much better when you also pair it up with the consequences.
hmm hmm
Like, every day that we don't fix this other thing breaks and ultimately leads to this. Because I think when you pair up with all of that context, which goes back to a topic that you already mentioned, it becomes much easier for people to decide what to do with the alerts, and maybe even more engaging because then you finally know like what's the effect that I have on this and why should I care about these alerts.
Right. I think that that's a very good way to look at it. You have to think about the whole life cycle from the
Yeah.
start of the event to all the way to consequences in your program, in your system, your data orchestrator, for example, all the way to the eventual stakeholders and the impact on the business. And it's just interesting you mentioned this because you also see a lot of people talking about stakeholder management and how do you talk with your stakeholders. Well, you got to speak their language, and you have to listen to what they want, and that's all great and all. But I'm always lacking a little bit of the specifics when people are talking about these things. It's very easy to get
Yes.
down to very loose ideas like we should communicate more, we should have a meeting. Like, that doesn't help get down on this. So just as you would make a data model, you have a stakeholder model. So we're very comfortable making data models. Why not do this with stakeholders and their needs? So
Ooh. Tell me about these stakeholder models.
so
I've never heard of them.
I just thought of it on the spot actually, but I think if you think about it, right, every stakeholder has a different perspective. Whether you're talking about someone in accounting, someone in marketing, someone in sales, they have their own goals and motivations. They have their own language, and they all have their own impacts on the business. So let's take finance for an example, right? Let's say you're head of data and you have to defend why your data team is valuable to the company. Uh, well, if you go into depth with the language that someone in accounting might use, is they might think of something like a cost center or a profit center or revenue center. And in very technical jargon, that just means, is this team doing something operational and just costing us money? Is this team bringing more revenue to the company? Is this team producing more profits for the company? So if you know this thing, that let's say they think about something like return on investment. So the current value of the investment minus the cost of the investment divided by the investment.
For
Um,
sure.
if you know these things, then you can start to break it down in something that they understand. So let's say we talk about costs, for example.
Sure.
If we talk about the company, costs could be all kinds of things. Well, if you look a little bit at balance sheets, the most expensive thing is people. So you can really do a lot of questions around that, right? So if you can, it's the same with the developer experience, right? If you save all these people 5 to 10% of their time, that means that there's a less man hour needed. And especially if a company's scaling, that's important. Let's say we have a customer success department that we need to scale as we grow in the amount of customers. If you can make it so that their scaling curve is more flat instead of more exponential, that's a huge cost
Yeah.
savings for the company. So you can kind of create this model of, okay, so for this department, costs are really governed by the amount of people, amount of customers, and how much time per customer do they spend. And then maybe if you talk more of them, you figure out it's all about call volume. And then what you want to do is, can you bundle more issues in one call instead of different calls? This is a very simple
Yeah.
example, but really, if you develop these models like this around your stakeholders, you can really start to understand what they care about, what really drives value for them, and then start to work on addressing that by saying, look, if we spend this time, if let's say these engineering hours, we can reduce this number from, let's say you need 10 customer care agents to 5 for the same amount of customers. That's a very concrete end goal, very interesting for the business. Um, I think all in all, it's a lot more clear for both sides where we stand. But it's always easy, and this is something I've noticed working in different fields as well. I've worked in academia, biotech R&D, healthcare businesses, and I've been changing, my profession as well throughout that. And I always notice that a lot of people will have certain language around their job and what they do and their view of the world, and they will start talking to other people in those terms as if they understand. They just assume that there's an understanding there.
Guilty.
We're all guilty of that.
Yes.
That's super normal.
They call people users. Just random people in the street.
Just users on the street, man.
So yeah, it's relatable.
But what I think is everyone has the same issue. If you're on the other side, if you're marketing talking to data, you're like, they just don't get what I'm saying. If you really want to move the needle, it doesn't. And I don't think this is specific for data. I think it's for any professional. Is you have to take the initiative to try to understand a little bit about what they do, what is their language, and how can I express things in a way that they would express things. And by you taking that lead, they will also reciprocate by trying to be more understandable about your terms, right? If you take the initiative, it's much easier to be reciprocal than just expecting it from the other side, which I
For
feel
sure.
a lot of conversations tend to kind of revolve with talking to stakeholders. And I'm like, well, these are all people just like you. They also want the same as you want. It's like, just explain me clearly why I should care, why this is important. Everyone has the same questions.
So here is a great idea for a business. Somebody should write a book where it has, like, let's say for data engineering, it has how to explain your job and your main responsibilities to different careers, and like how to explain to an auditor, how to explain to finance, and indeed integrating there, like they really care about these parts. And if you tell them this, they're more likely to like lower their defenses. And it just can be like a little elevator pitch.
Honestly, yeah, let's do it. Yeah. Perfect idea.
For sure. Yeah, that's a good one. Tony, I've been thinking of something. A lot of the topics that we're talking about right now to improve developer experience are very psychological, but we all started with dev containers. Can you think of other technological solutions that
Yes.
organizations can do to improve the development experience?
Right. Yes. So we've talked about the mostly analytics engineering experience there. Also the psychological perspective. Let's say we're talking about a data engineering perspective there. So you'll be writing a lot of custom code to manage your infrastructure, to manage your ETL or ELT pipelines in an orchestrator like Airflow, Prefect, or Mage, or whatever you want to use, right? Um, and I think there's also some guiding principles there to make this work better. So we're talking a little bit about Goodhart's law and what you should focus on testing. Now, uh, one of the most hard things, and I think anyone here can relate to that, when you develop a code base, is making it easy to make a change in your core system as it
Yes.
evolves. That's one of the hardest things to do. It gets exponentially more complicated. The more you've worked on a code base, the more complex it gets, all these things. And what I think is it's important to set some certain technical frameworks at the start or at any point, really, to kind of make that a smaller bump to overcome. Um, so we're talking about code bases.
Yeah.
What you really want to do is focus on loose coupling of your system. So what does that mean? We want to be able to develop all of our components in a way that they have the least overlap with something else. So if we're talking, for example, about running SQL statements against your database or data warehouse, it could be something very simple. We could have two components there, which is the SQL statement generation itself and the execution against the data warehouse. You want these to be as separate as possible.
Yeah.
So you want to be able to test them individually and not have to impact the other one. Because if I change my execution engine for running SQL queries, I don't. I might change some smaller things about how SQL queries are generated, but generally I wouldn't want to touch it too much, right? There's no need to integrate them together.
Yeah, for sure. And you definitely need to be conscious about the changes that you're making.
Mm-hmm.
It's always about the changes that you make without noticing.
Exactly. So, of course, you need to centralize things to make them more manageable on a company level, a team level, and all these things. But that's where it starts. You have to have a very good loose coupling design. Now, when it comes to developing the code itself, we're talking about testing, right? We want to make sure that we actually see that things are running as we expect. And I think, especially if you work in Python, one of the best ways to get started is actually use Pydantic. And I know right now we've had the bump to Pydantic 2 pretty recently. It's been the nightmare of a lot of migrators. But generally, it's a very good framework. And what I would like to call the data code model. So really thinking about how should we organize these classes and the variables and the functions. And Pydantic is a great way to get started with that. And what you really want to do is not have too much hierarchy. I would recommend having at most one or two levels, not more than that, because it gets very messy. And another requirement I would say is it has to be executable in a PyTest. And then I'm not talking about chasing coverage. That's not important at all. What I would say is you want to deal with smaller issues like, is the data that I'm providing the right format? With a library like Pydantic.
Yeah.
That's what it's for. It essentially helps you that if someone is putting in data into a class to make sure that it's actually the correct format. So if we're writing SQL statements, we can say like, look, you're missing like a table name or a schema name or something simple like that, right? All these things, we don't need to test that. That's implicit in the data model. So if you really spend enough time thinking about that closely, that helps a lot. Another thing in Python I would really focus on is doing proper typing. So you can use MyPy for this. You can use PyLens and really make sure that all your variables and functions and classes are properly typed. And
also type hinted.
Exactly, type hinted. You want to have types. You want to be as clear as possible with types throughout your code. And the neat thing about a framework like Pydantic is you can actually enforce it. So let's say we have a function that always has to return a list of dictionaries. I can use the @validate call decorator from Pydantic to actually make sure it always returns that. So if you think about it, that in itself is a test. It's already testing all these things like through assertions, and I think they had a specific term for it. They call it validation, right? So you want to do as much as possible through those frameworks. So you take away the burden of having to write a separate software test for it. So then we can completely ignore that coverage metric. I would more focus on your type coverage in your code, right? I think that's a much more productive effort of your time, and it really helps you prevent bugs and have unexpected behavior. And if it's hard to understand what the correct type should be, if it's an open source framework, you can just look up the source code, which I would recommend to any engineer. But there's also tools in Python like using vars and dir and functions like these that can essentially show you what the content is of an object or a function, and then you can use that to properly type in something. Um, I think the more you do that, in data engineering, that's a much more important thing to focus on than, let's say, testing coverage. Um,
Yeah, for sure.
right. So you could have a specific like engineering rule, like you want to have at least 80% of your class variables type hinted, and it should not be type any. That we should prevent as
Yes.
much as possible.
Or none.
Exactly. Don't use that all. In my opinion, the more you use that, the more it shows me you're unclear on what this thing should be doing, which is never a good thing. Except if you're writing like a really like abstract implementation. Sure, you can do that there.
Yeah.
Usually, you would have those at like the base layer of your code base. So you have like a lot of abstract base classes. Maybe you'll have like your own custom class vars to really define, let's say, the behavior on an abstract level before you get deep into it. That's
Yeah,
what I
it's
would
just a-
usually recommend.
Just that very few people have a good reason to do that.
Well, I mean,
Most people just do it because, like, oh, if you do this, then it works.
yeah, well, that that is the culture thing. You have to really, with I think data engineering code bases, you have to really be resistant
Yeah.
against that. So you should always have like an abstract base layer that everything inherits from, loosely coupled, very well typed, and then the step there is to introduce PyTest for integration tests. So I'm
Yes.
not talking about unit tests. I'm not talking about mocks. I think those are not. That's my hot take. I think that those are useless.
Oh, that's
You
interesting.
don't want
Yes.
to do that because the thing is, I don't care if the function runs. That should be sort of implicit in the code. I don't care if I've covered like this line of code. I care about the behavior in the system. And especially nowadays, we see a lot of innovation happening also on the data warehouse side of making things more complicated. I think we've kind of gone full circle
Yeah.
where everything was super complicated at the start, right? With like Spark clusters and Hadoop and whatnot, and like configuring all of this super complicated to something more simple, like a data warehouse,
Like-
especially Snowflake does that
Oh,
very,
yes.
very,
Okay.
very strongly. Databricks also, but less to some extent. But now they're circling back. Now they're like, oh, we support all of these modern table formats, and then suddenly you have to support this, and maybe you want to change that out in your code base. But then the question that you should be answering is not, does this piece of code run, but does it produce the same behavior for my system? That's the important
For
question.
sure. Companies and tools ultimately become slaves of supporting the things that they once provided.
Right.
Even when a new solution comes that is objectively better, they
Mhm.
still have to support the things that they roll out in the past.
Yes.
And that's why, like, it's kind of a cyclical thing of 20 years that new tools come and they only take the good parts, and then the older systems are still supporting the ugly and nasty things. But, uh, like, going back to what you mentioned, I do have an interesting anecdote about testing, and that is when I get it that when a lot of people build code from scratch, they might not see too much of a value in typing things properly or even doing tests. But when you enter a project and there is a very large code base, and I really hope that all of you listening to this get to experience this at least once in your life. If that project has been like properly tested and every single script comes with its own test and the integration test and everything is super clear and super well documented, the first time I saw something like that, I was like, wow. Because I realized, honestly, I don't even need to look too much at the code. I can just read the test, and that's the best type of documentation. That to me is like, this is how you expect the code to work, which is sometimes different to how you write and how it actually works. And then just the fact that you can just go loose and make some mistakes and not worry too much about like you breaking some other things you were not aware of because some tests will tell you, that makes a massive difference. So once again, I hope that all of you get to experience this, entering a project with a massive code base that somebody took a lot of effort and love to test and to create tests, and that you know for sure that what you're doing and what you're typing is not going to break something outside of it. It's a beautiful experience.
I totally agree. And I agree also that it also reduces the need to do things like documentation because it's clear through the test how things work. What I would also add to
How
that,
they should work.
how they should work. That is, yeah, that's a that's a good point. It's it also saves just a lot of development time. So a lot of times when I see um, migrations spiraling out of control when it comes to the amount of time it takes to do them, it's the testing that's the problem, right? So if it takes me a long time to test various components, if changing one part of the code base immediately destroys everything, it's a lot more risky, and people are going to start to like experiment less. They're going to start to refrain from changing the code base, and that's where you get stuck with legacy solutions. So the more you can do this, the more evolvability essentially you're introducing in your system. The higher the complexity, the higher the scope you can handle. Um, I think that's super important, but also for yourself. I mean, it just saves a lot of time. If something breaks, you can run the test and see at least be able to let's say tick off certain possibilities of causes, especially as your system gets more complicated and there's more layers in there. This can be very helpful to
Yeah.
reduce the time to a solution. And I would also say, like for yourself, if you think about more like a professional development, like learning new technologies and tools yourself, if you let let's give an example. Let's say you're interested in learning about like these newer file formats like Iceberg and Delta and Parquet and how they all relate to each other. It's very nice if you can write a little piece of code, a little test that actually tests things like how long does it take to process this data, what comes out of it, what's the shape of it, what does it look like. So you can essentially run small experiments before you actually introduce something in a larger code base. Whereas a lot of people then start from scratch. They're like, okay, wait, I saw this new technology, I saw this new configuration, and they have to think from scratch, okay, how am I going to set this up, write the code, blah, blah, blah. A lot of the times you're testing similar capabilities. So if you have like a set of tests to do all these things, you can do this a lot faster and kind of cut through all of that, let's say, repetitive setup work.
Yeah, for sure. Tony, our time is almost about to finish, but do you have some last tips for the people listening if they want to really improve the experience of their developers?
For the audience listening, just remember the time when you're editing a piece of code and you were super frustrated about how long it took you to change it because someone didn't document it, didn't test it, made a code spaghetti. Think really hard about how frustrating that was, and just imagine that you're doing that to other people if you don't structure your own code.
For sure, I think we all recognize that pain. So yeah, it's our responsibility as more senior data people to prevent all of that from happening to people, because to be honest, some of the people building the worst experience for juniors are the most experienced ones. So we also have some responsibility in there, and we need a lot of empathy.
Absolutely.
Great. Tony, thank you so much. It was a pleasure to have you here to have a chat. Definitely learn a lot, and I hope all of you listening enjoyed this.
It was a pleasure for me too. Thank you for inviting me.